All right. We have, like I said, we're beginning a section here today on matrices. We'll spend 3 days. Today will be mainly just the basics.
Guys, pay attention. God.
Calm yourselves. The note sheet is in front of you. You have it, so you shouldn't need to take notes in a notebook unless there's something, I don't know. I would just maybe annotate along the way on this note sheet. And including on this note sheet, there are problems to do that are left blank. So everything in this PowerPoint should appear word for word right here. So along the way, I'll just make some comments. You'll make some comments. We'll just celebrate matrices together, okay? So there's a lot of stuff that I'd rather not have you write down, right? Like, so here's a matrix. You would be here, A, 1, 1, 8, 1, 2, dot, dot, dot. All right, so there it is in front of you. Of course, matrices are an idea you've encountered before. And we're going to keep mainly away from applications today, but I'm sure, as you know, if you've had any experience with matrices before, there is an array of applications. Okay. All right. So we always label, we always read the dimensions of a matrix in rows by columns. So rows by columns. M rows by n columns. So if you're talking about a 3 by 4 matrix, you're talking about a matrix that has 3 rows by 4 columns. And no one ever does anything different than that. Rows by columns, okay? It's just a convention. It's just how we say it, okay? Elements or entries are what these things are called up here, like A21 is the entry in the second row, first column. So the subscripts there are also labeled row column. Lots of words here. Square matrix, if they're the same dimensions. The order of the matrix is sometimes also what we call it instead of the dimensions. Equal matrices, if all the elements are equal. Column matrix is one that only has one column. Row matrix is only one that has one row. In both of those cases, those two things in particular could be maybe thought about as vectors, which already maybe see some foreshadowing that there's a lot of connections here to be made with the rest of this unit. So in those particular circumstances, if you have a one-dimensional matrix, we're really going to be talking about a vector. Yeah.
So when you say the notation is A, I, J, does that mean, like, for example, like A11 is like I is 1 and J is 1?
Yeah, right.
Oh, okay.
How do you know which one A111 is equal to? I11.
Right, you need to use a slightly different notation. Sometimes you'll actually put commas in the subscript if there's any ambiguity. Yeah. I don't think, you know, this side of high school you'll need or want to encounter such matrices, but there's certainly ability. You can go there if you want. Adding and subtracting happens in the way you would expect. Add corresponding elements, etc. if they're the same order. Scalar multiplication happens the way you would expect. Just multiply, if you're multiplying your matrix by like 17, you just multiply everything in your matrix by 17, right? No surprises there. I'm going to skip right along here because this is right in your notes there. So let's start these problems. I'll call 5 people up to do these problems, okay?
I do number A. So,
because number is not A. Wow, she's
I'm not going to help you now.
no. Hey.
Sydney, A. We'll do A. Michael, you want to do B?
Why is D so long? 3 and 7.
Aiden, you want to do C? E tied B.
Oh no. Wait, which one?
Sorry.
You literally, oh wait.
The E on there.
Oh.
E,
Okay.
Stephanie, you want to do E?
Why is it undefined?
When you're ready.
Because
Come on up.
C is a 4 or 2 by 2, and then...
Oh, you're right. Forgot you could do that.
Yeah, I gave you
You gave me the good one. Redemption from yesterday. Hey, Siri, it's not your redemption, it's mine. Let me go on this app. Oh. They have to be the exact same, right?
Yes, because you can't, like, hire someone.
And do you, when you're doing addition, when you're doing addition, So for matrices, you just go 2 minus 1, so the
Trying to do
if I was doing A plus B, the top one would be 7, and then -5.
Right.
Okay, that's pretty good. Simple, that's good. Yeah. So smart.
Redemption.
Thank you.
I gave Stephanie the hard one.
Wait, shut up.
She's coming at you. For those who are done and perhaps bored by this, do you remember? I'd like to actually have you pull out your calculator here too. Do you remember how to do all this on your calculator too?
There's a bunch of words.
Whip it out.
Yeah.
Math matrix.
So while Stephanie's writing this up, let's just remind ourselves, or learn for the first time, how to use your calculator to do these. Right now it's somewhat optional, but there will come a time very soon, like tomorrow, where I'll be asking you to do something on the calculator that you just can't do or won't want to do another way. Okay, so well, yeah, and actually you know how to take a determinant on a 3 by 3 by hand now.
But I don't want to.
You're really good at it. You've been doing it with the cross product now a whole bunch.
All these people watching this video
But
next year are going to be
yeah, we're gonna find like inverses of 3 by 3s and stuff, all that kind of stuff. So on your calculator, for those who haven't done this before, you're gonna hit second and then your X inverse button, which is 3 buttons below the second button. It's the matrix menu.
I did it.
There are 3 column menus. When you get there, go over to the edit menu
Wait.
and
So,
choose
I got you, buddy.
and choose matrix. Choose matrix whatever. Choose matrix D and put this in.
Matrix D.
I don't know. I'm just saying pick one and put it in. Maybe put in matrix D. Enter 2 by 3. Remember to enter it just like we said. Row first, column second. Help the people out at your table. Make sure they know how to do this.
Wait.
2 by 3. By the way, someone check all the answers up here too. Are they right?
We only have to do D.
I can't find the matrix.
Does that have to be this?
So you're going to second, X inverse. No, it doesn't matter. Mode doesn't matter.
I
Go
found
over
the
to edit.
solver.
Go down to matrix D, say.
Look what I discovered.
Put in 2 by 3 and then put in all the entries. And then return to the home screen if you like. Quit out of there. If you quit out of there, it will still be stored though in that matrix D. And then when you return to the matrix menu, so you'll do that then. Return to the matrix menu. Choose matrix D, this time on the first menu when you get there, the names menu. You want to try this too? Make sure you know how to use all these features.
How do you clear a matrix?
You can go in and just clear it by hand, or you can go to your memory and like pull up the variable and hit del var or something like that. But I don't know why you want to do that. You just go in and clear by hand if you want to.
No, I'm supposed to do that. Can't you just like put, how would I delete this?
Oh, you go back to here. Oh, you want to use matrix N? Okay, 2 by 3. Okay, just type in whatever you want to type in there.
Wait, what do I do after?
All right, so go back to the home screen. Then go back to the matrix menu, pull up names, matrix D, say, if you put it in there, and then multiply your matrix by -2. See if you can get your calculator to output one of the answers up here. Or if you want to load in matrix A and matrix C or something, see if you can go here and add A plus C on your calculator to help each other out. Just check one of these. You don't have to check them all, but just make sure you understand how to use it.
Sorry,
What's up, GP?
I got special delivery.
Hey.
Any idea where the link is?
It's a speed trap.
Is that a big
Wait, hold on.
All right, any questions before we leave the answers on this slide? Are they right? Did you like them? Are you okay even with the last problem here that Stephanie did? Yeah, Brandon?
It's like -2b, right?
What?
It's -2b.
-2b.
Yeah, she said -2b, but then isn't, wait, never mind. I had it wrong.
It looks like she moved B over a copy of 2B over to the right side, it looks like. And moved Y negative 735 over to the left side. So I think we're okay there maybe. That's kind of cool though, right? We can answer some interesting questions
So
there.
like, if you answer the last question, like E removed from the calculator. I still haven't figured out what
E?
to find the
I don't know that there's a great way to do that in your calculator, really. I don't know. I take that back. There might be a way on that. It just, I don't know. Easy enough to do by hand though.
Oh, I don't like
All right, let's talk about matrix multiplication now, which is a little trickier
a 9
here.
by 9 matrix.
So here's the somewhat opaque definition of what we mean by matrix multiplication. And right now, we'll do one nice kind of real world example that explains why this is a good way to do it. But right now, there's a little bit of like, just trust us, like that this is a good way to do matrix multiplication. Your first inclination might be like, oh, okay, well, we just multiply entry by entry. But anyone who's done this before remembers that that's not quite how it works, and it's not. It'd be nice if that was, but it's a little more complicated, right? So this picture kind of says it all. From matrix A, if you're doing A times matrix B, you do the rows from A times the columns from B. So notice that this entry, for example, here, which in the product matrix is in row 1, column 2. That's the result of multiplying row 1 from matrix A and column 2 from matrix B. Now, how does that result in one entry? Well, we'll go over here for a second. What this says is you multiply A11 by B12 up here, and then add it to the product of A12 and B22, right? So actually that should be familiar. That's basically just dot product, right? So you can see how this works. There are a couple things to note, of course, as we do this. This requires a very special set of matrices to even have the product be well defined. This yellow row needs to have as many elements in it as this yellow column from B, which means B needs to have the same number of rows in it as A does columns. Do you see that?
Yeah.
In order for this to be well defined, can you imagine if that weren't true, if there were like, say, 3 rows in this matrix? Then you do like right? That would be a problem. Be a problem. So to put some letters to it, say you have an m by n matrix A, and you want to multiply that by well, the number of columns in A, which for us here is 2, needs to be the same as the number of rows in B. So the other matrix for this product to even be well defined, this needs to also have the same dimension here. And then the other dimension can be whatever you like. J. I don't know, just make it up. All right, and then furthermore, first of all, it's defined only when these two dimensions match. Right? That is the number of columns in A and the number of rows in B. And second of all, we can actually also say, just from this little cute analysis, what the resulting dimensions will be. And what will those dimensions be?
4, 3.
Yeah, m by j will be the resulting matrix size. Do you see that here? So notice that, I mean, this is a little weird. You have to kind of, like I said, this is an act of trust on your part to be like, this is really worth doing, like in learning. I promise it is. Okay. And some of the most beautiful applications will come in the next couple of days. But right now, we'll just learn the nuts and bolts. So let's actually kind of, I intentionally chose matrices that are exactly the same dimensions as the ones in the picture. So let's actually try and do this with some numbers and see that we understand the mechanics of it. I'll handhold for the first 1 or 2 here. So we're going to multiply A by B, and we're going to get a 4 by 3 matrix here. So here goes nothing. All right, here we go. I always like to, we want to go row by column. So we get 6 plus 0 for that very first entry, whatever that comes out to. I don't know what 6 plus 0 is, okay?
6 plus 0 is 5.
All right, and then now I'm going to stay with the same row here, second column. Oh, this is a tough one. 0 plus 0. Okay. All right, next, Same row, third column, -3 plus 0. So far, so good?
Yeah.
So -3 times 1, and then 0 times -1. All right, now we're down to the second row finally, and we repeat. -1 times 6, and okay, so that's -6 plus 3. Okay, second row times first column. Now, second row still again. Second row by second column. 0 plus 6. And I'm running out of colors here. Okay. Second row times finally third column. You getting the feel for this? 3 minus 1. 3 minus 3. 3 minus 3. Finish it off. And when you're done, some of you already are, check it with your calculator. Load both of these matrices in, multiply them, and see if you get the same result. I need you to be able to do this by hand. I also need you to be good at using the calculator, both. Yeah.
So the number of rows on A has to be the same as the number of columns on B, right?
The number of columns on A has to be the same as the number of rows on B.
Okay.
These right here. So let's just write out the answer now. So 6, 0, -3. I got all these here. -3, 6, 0. All right, let me do the other ones here too. 24 minus 2. Is that 22 there?
Yeah.
And -4. Check me on these.
It'd be next every time.
-10, right? 34. 8. Again, check me on these here. -19. And use your calculator too. Check me on these, right? Yeah.
You have to include the word like six.
No. I just was doing this for those who have never ever encountered this before. I wanted to go color code it, go nice and slow. But in practice, I would probably never write all this. I would just, I'd think about it carefully, but I would just write the answer probably. No, I don't need to see your work on these.
We did like the first week of like last year in like 10 minutes.
Yeah. This is like everything you might have learned in AF. We're done now in 10 minutes. Okay, good. Did you check with the calculator too? Did you get anyone have practice doing that on the calculator? You know how to enter these? Okay.
All that makes so much sense.
Do you want some more practice? Yes. I hear you say. All right. We'll do that in a minute here. Oh, yeah. What's BA? BA is undefined, right?
Oh yeah.
All right, so a few notes about matrix multiplication. These are on your sheet. Listen, guys. First of all, the product sometimes doesn't work, okay? So that's fair to see, like BA doesn't work. When it does work, both ways, it doesn't necessarily give you the same thing. In fact, generally not, right? Here's an example of, I just put on there, of a matrix product that you get two different answers here, right? AB, BA. In general, matrix multiplication is not commutative, okay? That's not as unsettling as it might be for some people because you've already encountered the cross product, which isn't commutative. So we're like, okay, maybe at this point you're like the things that don't commute. There are lots of things in life that don't commute, like your washing machine and your dryer or something, You can't do those. They're ordered, like, okay. Here you go. Well, they're in your building. An interesting question for research for you would be: are there a set of matrices that do commute? Right? Are there any matrices that you can find that are non-trivial that do have this property? Right? I just mean like the all zero matrix commutes with another all zero matrix or something, or whatever.
All one.
Huh?
All one.
All ones, maybe, yeah. So maybe there are some, it's less trivial. Okay. And then we already mentioned that this is just the dot product. Let me highlight from the product above as an example here. Right? It's just the dot product, okay. is how we're computing. Come on, give it up for my animation skills.
I'm shook.
We won't click on this, but one could click on this, and it gives you like a very careful walkthrough on matrix multiplication. It sounds like you guys are in a place where you're good at this. If you're like pretending like you're good at this right now, go home and look at, okay? Become good at this. All right, go ahead and do all these again by hand, and then afterward check a couple or all of them with your calculator. I'll be calling some people up right now.
I already got called, so my sleep's already out, so I don't have to do that. I always have to work, or else I won't get the mental stimulation that everybody else.
I got each side for all of them. Yeah, I put a bunch of copies of your stick in there.
Oh, yeah.
Holly, would you do the first one? First Holly. I'm going to do that first one.
I wasn't serious.
Lydia B. Did you hear me, Lydia?
The microphone fell down.
Yeah, I kind of did. Lydia, you got B. Brandon, you want to do C, please? Anya, D. And is Jasmine in the house? Three, would you do?
Okay.
Would you do E?
Yeah, I would love to do E.
Thank you for your volunteer.
E for E-type.
So come on up. Whenever you're ready, in any order, people who have those, who I call. Everyone else, keep slogging away at these. Become good at these. Become good at these.
I just think my stick was in there, and I'm kind of happy with it, but apparently it's not. Okay.
It's gonna be a live performance.
Live performance.
Right?
For this, can we represent it with a dot?
Negative
Or an X, it doesn't matter. For matrix multiplication, it can be a dot or an X, it doesn't matter, like if it's vectors.
I don't know.
Yeah, there's not like another kind of matrix multiplication.
Hey, why
I
is
just have to
it
go undefined. You got this, Brandon. Wait, what is going
Again,
on?
if,
Brandon, why are you so
The number of columns was the rows. So number
What are you
A
talking about?
has 2 columns.
You know what you're doing? Okay, so
No.
Oh, no,
You're
it's
blocking the
not
screen.
There's 2 columns.
I'm
it
kidding.
helps, I think, to write down the dimensions.
Negative 4 and
Of both.
8. Okay, yes.
Isn't it always going to be
Negative 1 or 1 plus 4.
Yeah.
Or 1 times 0 plus 0 or 1.
Oh, you're multiplying. Okay, so basically to find the first.
Hey, I already got it. I already got it.
Okay, so it's done.
Yes. Here. Thank you. Thank you for trying to help. We know.
So the result is going to be 4 by 2.
Do you know?
Oh.
So we just went undefined. Just went undefined.
Oh, okay.
Your head's in my way.
Like when you write dimensions, it's like the.
This is just gonna take you more
The
time.
truck. That's why I got 4 by 4.
There's a, you guys know the row by column?
Kale, Kale
By
and
column. Row by column.
Oh, that's an animal farm. It's
Why is it undefined?
Oh my god.
I'm not even dumb. I can see the general shape of your hand without even moving.
How are these guys doing? Getting right answers? You check with your calculator. How are you doing? Are you getting right answers? Can you do it on your calculator too? Do you know how?
Wait a minute, what's the heck?
Not quite, but maybe I'm just so good at doing it in my hand.
Holly, you come. Got it. So are we good? We got 2 here that were undefined. Interesting. Okay.
Can I just see? No, they're not inappropriate.
Level of maturity.
Making exams so bad. I just wanted to compare answers, and you were all suspicious of me.
Is there any additional? Is this okay? Is everything okay?
Yeah, it's 6 minus 70.
6 and negative 70. Are we good now? You like them all?
Wait, what's 9 times 5? 45. Oh, okay, yeah. Okay. I was checking.
We good on these?
Wait, so
Questions, comments before we go off this page? Hopefully at this point in life you are now an expert at matrix addition, subtraction, scalar multiplication, and matrix multiplication. Okay? And doing all those things with the calculator. Alright, last we'll end with a slightly useful real world example, though it's a stretch, but alright. Please, the instructions, if they're not clear, the instructions here are please load into a matrix all of the equipment needs for these two teams. Into another matrix, load into that matrix all the costs. And then choose an appropriate multiplication to do that results in a matrix that gives the total cost for each piece of equipment that we need. Okay, so the task here is not really the arithmetic as much as can you come up with a matrix multiplication that makes sense in this situation? If you think you have it, let me know. You can have one that makes sense. I mean, I realize you could solve this problem without using matrices as well. True story.
We spent an entire 45 minutes.
Oh my god, it's a camera.
It's a yeah.
How?
Wait, so like, why are we looking at videos?
It's a really pretty desk.
So they don't got it yet.
Okay.
I'm still working.
Katie, how did you get it so quick?
I didn't get to know why. Usually I understand
Let me see, let me see.
wait, so like,
Oh my god.
is it one all by 45 like this?
like, and I
Well,
was
where's the, no, I want one matrix. No, I want one matrix that contains them all.
Wait, is this one supposed to look like my sister?
Okay, keep going. Tell me what you're going to do.
Oh, I'm gonna multiply.
I don't know how to do it.
3 by 2 by 1 by 3.
I think this is scalar.
Where did you don't really think
So let me take notes today.
Nope, I did it wrong. I got it wrong.
Anyone have a matrix products?
Wait, is there a scalar function?
Not quite.
There's a scalar. So like,
No. I want two matrices. I want a matrix that has all the equipment numbers in it, and I want another matrix that has all the costs in it that you're going to multiply.
Oh, is it not this?
Oh, wait, that.
So it's like, it's not anything complicated. Like, one's like just have that. It's just something.
Wait, I want
That's
to
wrong. Wait, why? It's like, it wasn't just a.
Wait, but it's for each team.
I want you to have two matrices. I want all these numbers up here.
make sure change Chris was first.
I have no idea what I'm doing. Nothing makes sense.
1 by 3 by 3 by 2. Aha!
Wait,
Alright. Alright, we have two options. Alright. The reason I didn't tell you immediately is because there are two good ways to do this. Here's one way. Do you see it?
That's fine, guys.
God, that's what I did.
Fine.
Do you see that? Does that work? A 1 by 3 by a 3 by 2? What will the resulting matrix be? It'll be a 1 by 3, right? A 1 by 2. It'll be a 1 by 2, right? And that will be the total cost for each team, right? What about this one? Does this work too?
That was so cool.
Can you,
Absolutely does.
could you do that one too?
Yeah.
Yeah, 2 by 3 by a 3 by 1, and you'll get a 1 by a 2 by 1, right? It'll contain the same information though, okay? That's why I wanted to put it out to you, because I was like thinking we'd see both of those, and we did.
Yeah, this was the whole matrix.
All right, you are You are, I think, well prepared for homework number 9 from the book tonight. And tomorrow we'll do more matrices. Yay. It's just the beginning, my friends. Just the beginning.
And your brain.
Wait, Mr. Chase is
Mr. Chase did not find that video entertaining whatsoever.
You look like that boy meme.
Oh.
I kind of want to see it.
Yeah, look it up on your